Hello and welcome to the main circuit revision video from scienceworksheets.co.uk. Please like, subscribe and comment to support the channel. The electricity is first produced in a power station and then it will be distributed across the country using the national grid. From the power station, the electricity is passed through a step-up transformer which increases the voltage from 25,000 volts up to 132,000 volts for transmission across the network of pylons and cables. The electricity then passes through a step-down transformer where the voltage is decreased from 132,000 volts to 230 volts to supply electricity to our homes. The national grid is a network of cables and transformers that allow electricity to be transferred from power stations to where it will be used, such as homes, shops, factories, etc. So it distributes electricity across the whole country. Now, in order to make sure that transmission is going to be efficient, the step-up transformer increases the voltage or potential difference, so the electricity is transmitted as a high voltage or high potential difference and low current. By keeping the current as low as possible, it will reduce the amount of electricity that is converted into heat energy, so it makes the transmission far more efficient. If the current is high, then a lot of the electricity will be transferred into heat energy, which is not what we want. Once the electricity reaches our homes, a plug is pushed into the wall socket to allow the electricity to reach our appliances. Now, the wires inside the plug are made up of copper, which is a good conductor. It's also relatively unreactive, so it doesn't oxidize easily, and the copper wires are insulated by plastic. Inside the plug, the brown wire is the live wire, the blue wire is the neutral wire, the green and yellow wire is the earth wire, and we'll have a look at what each of these wires does shortly. There are two types of cable. We can get 2-core cable, which has a live and a neutral wire, and there is 3-core cable, which has a live, neutral and earth. For an appliance to work, you only need the live and neutral wires. The earth wire, however, is a safety device, and we'll have a look at what that does later. From the plug, the electricity will flow through the brown wire or the live wire to the appliance. Now, the current that flows along that will be an alternating current, so that means it's constantly changing from plus to minus. And mains electricity in the UK is 50 Hz, so that means it changes 50 times per second. Once the electricity reaches the appliance, the neutral wire acts to complete the circuit, so it provides a return path. And so the electricity can go from the appliance through the neutral wire back to the plug. Now, the neutral wire is normally earthed at the local substation, so it should be approximately 0 volts. The earth wire acts as a safety feature on appliances, and it connects the metal case of the appliance to the earth. Only metal cased appliances will have an earth wire. Plastic cased appliances do not have an earth wire. They are said to be double insulated. So this is why when you've got 2-core cable, it will be used for plastic cased appliances. So 2-core only has a live and a neutral wire, but a 3-core wire, live, neutral and earth, will be used for metal cased appliances. The earth wire permanently connects the metal case of the appliance to earth. So if the appliance becomes faulty and a live wire inside the appliance breaks and touches the metal case, electrical charge would flow from the wire onto the case. However, because the earth wire is connecting the case to the earth, the charge will then flow from the metal case to the earth, and this will prevent an electric shock if someone touches the metal case. A fuse is a thin piece of wire between two metal end caps, and it's a little bit like the Achilles heel, because if too large a current flows along that fuse wire, the fuse wire will become hot, it will melt, and the circuit will be broken. Each fuse has a rating in amps, and this is the maximum amount of current that can flow along that fuse. So a 5 amp fuse allows a maximum current of 5 amps to flow. So an appliance that needs 4 amps for normal operation will need a 5 amp fuse. If when that appliance becomes faulty, a larger current is drawn, say 6 amps, then that will cause the 5 amp fuse to become too hot, it will melt and it will break the circuit.